Thank you very much for having me and giving me this opportunity to talk about some of my thoughts on the challenges and opportunities for the connected car. Um, so, if you've been following Qualcomm and automotive, you would have heard the term digital chassis. So, what does a digital chassis mean? It's really four different pillars. There's auto connectivity, which is where I sit. I'm the head of engineering for telematics. There's the cockpit or the infotainment subsystem, which is what you interact with when you get in the vehicle. There's RIDE, which is our autonomous AD subsystem. And we have car to cloud, or what we're calling connected services nowadays, which cuts across all these three pillars and provides services in vehicle as well as in the cloud. And these four pillars form the foundation for the software-defined vehicle as we see it in Qualcomm. So when it comes to connectivity, sorry, I'm used to moving around. When it comes to connectivity, we've been doing this for a very long time. We have about, we've connected more than 350 million vehicles to cellular. And we're starting to see a accelerated shift from 3G, 4G towards 5G. What does vehicle connectivity entail, right? So within the vehicle, you have connectivity like Ethernet, CAN, LIN type of connectivity. From the vehicle to the charging infrastructure, you have something like power line communications. And as far as wireless goes, of course, there's WAN, wireless LAN, both in vehicle with access point in the vehicle and station connectivity outside the vehicle. Automakers are starting to show a lot of interest in satellite connectivity to the vehicle now. And then, of course, there's short-range connectivity like Bluetooth, BLE for safety, V2X, UWB, and so on and so forth. With all these connections to the vehicle, you obviously want these connections to be extremely secure and reliable. And it's also very important that we have software frameworks in the vehicle that allow you to develop applications and services that can leverage these technologies and also help you deploy those services in vehicle much more easily. So with that, I just wanted to talk about this in-vehicle network. It's a very simplified picture of the in-vehicle network. You have the telematics control unit, or the TCU, which is the connectivity gateway to the vehicle, which connects to ADAS and infotainment ECU through an Ethernet fabric. Now, I've shown wireless LAN. WAN is always on the TCU. Wireless LAN, Bluetooth, BLE could be on the TCU. Wireless LAN could also be on the infotainment ECU. CV2X could be on the TCU, or it could be a sensor on ADAS, or it could be on the TCU and still be a sensor on ADAS. There's many different configurations that automakers could go with, but this is a typical picture. I wanted to show this because it's a little easier to relate to what I'd be talking about in the next slide. So with that, just wanted to talk about some auto connectivity challenges and contrast them with smartphone, because a number of these technologies that we use in auto are leveraged heavily from the smartphone. So I showed you the TCU in the previous slide. Now that TCU in the vehicle could be anywhere. It could be behind the dash. It could be in the wheel well of the car. You need to be able to run RF cables, coax cables from the TCU to the antennas, which are typically on the outside of the vehicle. There could be 2 antennas, 4 antennas. And that basically, and these cables have to be concealed, which means these cables could be quite long, which translates to cost, which automakers are very concerned about. A degraded signal adds to the weight of the vehicle. These are all concerns that automakers are typically very concerned about, not something that we worry about on the smartphone. Now, you could move the TCU up into the roof and eliminate this problem, but that creates a new problem, which is the operation at high ambient temperatures. At the in the right under the roof in a car in the middle of summer, you can expect the ambient temperatures to get pretty high. So automakers require these chips to operate in pretty harsh conditions, high temperature, high humidity, for a very extended duration of time. 15 plus years is the typical lifetime of a vehicle. And on the smartphone, we don't have to worry about such extreme requirements. And automakers require the chipsets to go through certain certifications that prove to them that these chips are actually capable of operating in these harsh conditions for these extended durations of time. Again, not something that you worry about on the smartphone. I talked about long life, 15 plus years in the field, which means that you need a OTA system that can update software, kernel upgrades, security patches, so software, firmware, applications that need to be updated in the vehicle, not just in the TCU, but in other ECUs in the vehicle. Traditionally, automakers do have the OTA solutions, but they've not been very robust. And I think with the advent of the SDV and the EV, we're starting to see a renewed focus on that, and we do expect to see it get better from here on. On the smartphones, on the other hand, of course, all of your phones are updated quite regularly, and that's no longer a problem. Coming to standby power consumption, this is actually a pretty important metric for automakers because they want their vehicles to be reachable for 3 or 4 weeks or even 5 weeks after the ignition's been turned off. And basically that means the modem is drawing power from the battery during that period. And that becomes an extremely important metric. They want to be able to, remote door unlocks or pull some data from the vehicle during that period of time. And when you get back from your vacation and turn on the engine, it still needs to start. So this is a very important metric. Of course, it's an important metric on the smartphone as well, but you're not keeping your phone uncharged for multiple weeks at a time. Precise positioning in GNSS, thanks to autonomy and V2X, the accuracy that you need with GNSS and location services is much higher in a vehicle than in a smartphone. V2X, we have, from a product standpoint, we're in our 4th or 5th generation of V2X. Due to certain spectrum and regulatory reasons, V2X hasn't taken off as well as we had hoped. We still believe in the power of V2X to save lives, and we're still quite bullish about this technology taking off in the coming years. And then finally, security and isolation. With all these vehicles being connected to the network and the importance of autonomy, I don't think I can overstate the importance of security to connections to the vehicle as well as security within the software and hardware security within the vehicle. So with that, I'd like to talk about some opportunities, right? So we have the opportunity to make connectivity to the vehicle more reliable. For example, multi-SIM capabilities. If you're talking about automated driving, you having some redundant connection to the vehicle could be quite important. So there's an opportunity to make connectivity more reliable. There's an opportunity to make connectivity more safe with CV2X. CV2X as a sensor to the ADAS subsystem with autonomy or not. We have an opportunity to make the connectivity more ubiquitous with satellite connectivity to the TCU. You have an opportunity to provide better location services. ISO 21434 is a cybersecurity standard that every automaker is required to be compliant with starting this year, which basically means that all the software and hardware component vendors who supply to the automaker also need to be compliant with the standard going forward. So it's just not just the connectivity security for the connections that come to the vehicle, but also security of the components within the vehicle and the software isolation that you can provide between different domains within the vehicle. And then we have the opportunity to provide software frameworks and application frameworks that allow easy development of applications and services for the vehicle and deployment of those services in the vehicle. And every single one of these areas are likely to be beneficiaries of artificial intelligence in the coming years. So with that, just wanted to very quickly talk about wireless and AI/ML for telematics. Obviously, the first three things there, predictive channel state feedback, millimeter wave, beam management, ML-assisted position location. These are all areas of active research within 3GPP, as well as the industry. And telematics is likely to be a beneficiary of all the work that is being done to enhance wireless and location with AI and ML. Traffic classification, not something new. Work on this with heuristics-based approaches has been active in the industry for a very long time. I think AI/ML could take it to the next level, which would allow us to provide services with differentiated quality of service at the edge. Intrusion detection, tying this back to cybersecurity, being able to predict intrusion, being able to detect intrusion using AI/ML could be very interesting. It could be a great area of research. Predictive coverage, being able to determine the best network for a given route, being able to use the best subscription in the case of DSDS for a given route, and being able to provide the best QoS for the vehicle, feeding that into route planning. These are all things that are quite exciting from a telematics standpoint, and I think every single one of these areas would have a very great impact on telematics. So I'm sure someone showed this slide yesterday or maybe later today. So I think with 5G and 5G Advanced, the networks were not designed with 5G or AI/ML baked into the network design. On 5G, models are being brought in on the edge and in the network, proprietary models in order to enhance certain functionality. And 5G Advanced, there's talk about how the cross-node coordination could improve that functionality. Coming to 6G, the idea is that you bake AI/ML into the design of the system such that every single layer and every protocol is impacted with AI/ML. And you have AI autonomously working between the device and the network across every single protocol and every single layer in the network. So with that, we talked about how AI could help wireless, but wireless helps AI as well. I said this before, CV2X could be a sensor into the ADAS subsystem, providing a non-line of sight input for path planning. Obviously, I say optional because not every vehicle has CV2X today, but for those vehicles that do, this could provide a positive input for path planning. Coming to WAN connectivity, obvious stuff, uploading training data to the network or being able to download ML models into the device, whether it is a TCU or cockpit or ADAS. And these are not probably not very time sensitive, but if you are doing inferencing at the edge pulling data from the network or doing inferencing in the cloud, you would need wireless connectivity that is low latency and highly reliable. And I think we do have that with 5G as well as all the various different opportunities that I talked about in the previous slides. So coming to the cockpit. There is a ton of contextual information in the cockpit, and there's a lot of personal information, whether it is the driver or the passenger. And AI could use this information to provide very immersive experiences in vehicle. You could provide services like digital assistant using intelligent voice control. You could provide intelligent route planning with predictive coverage that we talked about a couple of slides back. Predictive maintenance recommendations for the vehicle. And AI could learn about user preferences and apply them in vehicle when it detects the presence of the user. So I think the AI could be, the cockpit could be a real good incubator for very interesting use cases and services that utilize artificial intelligence. So this is my last slide, generative AI on the edge. Now, to basically achieve everything that I talked about in the previous slide, there has to be inferencing done on the edge as well as in the cloud. These AI models are going to continue to evolve, and we need to be able to keep up with that, be able to provide a framework on the edge, on the vehicle, that allows us to update these models on a regular basis. So I think the SDV is going to play a very critical role in keeping up with the generative AI landscape. Thank you.
How did you like the talks from Fan and Siva? Glad to see the audience building up. I think yesterday John Smee did an awesome job in attracting a very large audience, and of course the subsequent speakers and panelists as well. So today we're gonna, with the same theme, we're gonna extend our conversation around wireless in automotive and how AI is gonna bring about a change. We saw a glimpse of some of the examples that both Siva and Fan alluded to, and we're gonna drill a little bit more upon them. So my first question that I have planned for the panel is that, like Siva was talking about similarities and differences of bringing smartphone into a car experience, what do they think are the automotive OEM's perspective of bringing parity of the smartphone experience into the vehicle? How connectivity can bring that parity, as well as with the generative AI coming in, what are the challenges that they see connectivity can help solve going forward? So maybe I can start with Venki.
All right.
Yeah, go ahead.
It's always good to be the first, so I can say some things what others cannot say. So. All right. So, before I start, let me at least give a background of XPeng Motors, because I'm not sure how many of you have heard about the company. So it's a EV company in China. We've been around for 10 years. And one of the selling points of the company is that we call ourselves a smart EV. So we have L3 plus solutions that we have deployed in mass market almost for 3-4 years now. So almost 250,000 vehicles I've been doing are on L3, and we have a pretty impressive usage rate. Almost 80% of the people use our L3 software. So that's the perspective I'm coming from. Now, in terms of what Shiva put and where we had the questions, right? So if you look at all the new cars that are coming in, new models of cars that are coming in, I mean, the amount of electronics and things that are put in the cockpit are amazing, right? I mean, you have like really big screens and all smart assistants and everything going on. So the kind of experiences that people expect, especially once you also have autonomy, is almost the cars are calling it as a home away from home, which means they want to have a very nice this big home theater kind of system that is there. So there's a lot of requirement on media, right? Being able to display high definition videos, and then you should be able to work from your car and things like that. So that's one of the, I think, main things that the new smart EVs are coming up with. So pretty much everything that we get on our phone, just expand it 3 or 4 times, and then that's what you want in a car, just like how you have an experience at home. So yeah, I would agree to that the requirements on the cellular connectivity is high, purely coming from all these applications that you have on a smartphone, except that a car is fast moving. So, make sure that you are able to achieve the same data rates on a fast moving vehicle, which can move around in urban canyons, in blockages, in tunnels, and so on. So that's where I would come from.
Thank you. Nuria, would you like to add something to it?
Yeah, I mean, I think I completely agree about all these comments so far. But this is from a perspective more of the infotainment, right? But I think there are other considerations, for example, related to this achieving this fully situational awareness. So there, sensor sharing becomes really important, and it's going to introduce hard requirements into the connectivity, right, that you need. If we are talking about really sharing raw sensor data, we are going to need to share a huge amount of data. I think it's gonna be even more than the infotainment applications. Regarding that, you can also say, well, maybe we don't have to share raw sensor data, but that introduces other legal issues related to who is responsible for data which are processed. So all these considerations, depending on what are your decisions about what you want to do as when you build your car and when you equip your car, are going to create different connectivity requirements. So I think it's a little bit about what are the needs of what are the trade-offs people want to make the automakers complex situation.
Perfect. Yeah. So looking beyond the generative AI and other wireless improvements that AI is going to bring in, any differentiated features in the telematic control unit beyond what Siva was talking about? Yes, there are some points that 3GPP work items and study items is definitely exploring. From academia and from automotive perspective, are there any differentiated features that automotive OEMs are looking for in the telematic control unit? Because typically we only, like you guys are also talking about, focused on the infotainment. That's where the consumer and the driver is interacting with. But focusing on the telematic control unit, what do you guys have and ideas about how AI is going to differentiate those products? Maybe Dinesh, I can start with you.
So I think maybe just to comment a little bit on the earlier point as well, right? So perhaps the way we think about safety is very different, right? And in the sense that it's a expected cost of the liability of how many accidents will take place and how much the cost of that is associated versus putting the additional sensors, right? And the total cost in the volume for that additional sensor, right? This is the trade-off they make. And that's what economically makes sense, right? From most automakers, right? And their perspective, right? And in this regard, I think safety, I think you go read up at the DMV's database, right? I think if they cared about safety, they would have put LiDARs and everything else on Teslas long ago, right? So, but infotainment on the other side gives a user added value, which we as people are willing to pay sometimes, right? I'm in the middle of nowhere. I want some internet. I just want to get some work done. So make sure I want to have that, right? So that's how I guess perhaps the most automakers think, right? If this adds a value, and for example, Tesla sells a $10 premium plan, right? You can get your additional connectivity LTE from your car and you pay $10 a month. That's money making for them, right? So there's a value add, right? So therefore, the initial point of approach for this, like all these connectivity getting into the entirety of the car, makes sense from the infotainment point of view or the providing connectivity point of view. And later on, as this becomes more and more pervasive, this will become useful for safety and other use cases. Then it becomes a tack on to that, right? So why not? Then that makes sense. Now, the second point to coming with the generative AI, right? I think like, for example, there is a new concept of photon to control, right? Where basically what it means is that they've been coming up with these advanced ML models, foundational models, which essentially takes directly the sensor data and comes up with a control. Actually, to be honest, we have experimented with several of those in our lab and they do actually quite well, right? The only problem is their interpretability and other things which we have discussed even yesterday becomes really hard, right? So a lot of the focus, at least, is on building guardrails for safety, right? Along, okay, what if this car doesn't collide, right? What do we make sure to do that guardrail, right? Now, building this guardrail, right? That's where really within the context of generative AI, right? Where everybody's moving towards photon to control, building these guardrails will come from the side information which we accumulate from different cars, right? And this is where connectivity will truly play a big role, right? And this is where at least I see as we evolve, right? I think increasingly, like we should think of a communication paradigm where sharing generative AI based embeddings becomes the standardization within the SAE bodies at some level, right? Like I think I'm just going maybe really ultra par, but like right now, for example, SAE has some standardization on what should be the packet structure should be, how should they carry the information about people. There are different types of packets which carry personal information regarding persons, information regarding cars, information regarding different things, right? So these are the type of things which already are being standardized. But imagine the standardization going forward into sort of these embeddings which can be shared across cars, right? Again, then it becomes a concerns of security, safety, and all those other things, right? I think this is where I think we should start thinking already right now as we think about these generative AI.
Yeah, ultimately everything is connected, right? All the stakeholders need to chime in and make sure that from safety, security, connectivity, and ultimately, if you think about it, the generative AI is going to be the main driver of AI. Yeah, it is good to hear all these viewpoints. Anybody else, Siva, you want to add something to it?
No, I think basically, as I was saying earlier, today you have connectivity in the vehicle with cockpit, with ADAS. I think it's going to drive the usage. Not just, I mean, you have 5G in the vehicle today. Ultra low latency is something that automakers want. It's not really deployed today, but I think it is going to become a requirement. And there are other features like multi-SIM capabilities that exist in the smartphone, have existed in the smartphone for a very long time. Automakers are not necessarily asking for it, not everyone. There are some automakers who think it's extremely important with their automated driving now, some of the automakers. So I think that landscape is changing. Some old features will come into vehicles. Some new features that are yet to be deployed by the network vendors will be asked by automakers. Whether they'll happen or not, it depends on how important the MNO thinks it is, given the volume and everything else.
I had a question, maybe Siva and others know. So Toyota actually deployed 10 million cars in Japan with DSRC. This is perhaps pre-CV2X, right? Not to, I think the point is, I guess, what if anybody kind of has a sense of what was the value add they were able to add, if anybody knows.
Actually, I think Fan can talk about it. GM's deployed with...
It's the topic of a whole dedicated panel discussion. There's so much of pros and cons and opinions about DSRC and V2X and
it's
CV2X.
not about
them, go ahead, Fan.
Yeah, just about connectivity generally.
So I would say that the V2X peer-to-peer is a long journey. And 2 decades ago, and started from Berkeley Pass and several OEM, including Toyota. We kind of have this camp consortium try to get there. But this V2X, in fact, here's a few commercial deployment. Toyota one. I don't think it's to that large scale in Japan. It's a smaller than what the number you mentioned. And Volkswagen have a really decent and deployment and in German, and my employer in 2017 has such a deployment in Cadillac. And so all those things, but it's very hard because the V2X fundamentally is I help you, you help me. It's a cooperative system. It's very hard for one car makers to do that because they didn't, all the surrounding cars is not equipped with that one, and you will not benefit them, they will not benefit you. So this need a coordinated and a very, that's V2X is a very complicated business ecosystem, which need all the multiple OEM and need government, because many of the road infrastructure is controlled by federal level Department of Transportation and the state level transportation. But one pleasant and progress we have seen starting from late of last year is federal DOT and the state DOT begin to push more and for this road infrastructure V2I deployment, and which is really, for example, traffic light. They really provide the so-called signal timing and the phase information, when it's going to be green, when going to be red, and you can really have please slow down, and otherwise it will become red light violation type of application. Customer can immediately have this benefit, because I think I once saw some numbers, intersection crash is a very high percentage of among all of the crash. So we see very encouraging and progress on that part, and but it's still a very complicated ecosystem. Siva and I just talk about how the different parties and can work together to drive this societal benefit. And that one still remain to be seen.
Understood. Yeah. So I'm going to pivot a little bit because he brought up V2X, and V2X is a sensor for ADAS as well. So I'm going to pivot to autonomy. And there is a view held, and some folks have this opinion that L4 plus L5, you do not really need connectivity for those kind of autonomous vehicles, self-driving vehicles. What, in your guys, do you think connectivity is going to assist autonomous driving progression, or is it going to abate it, or any other conflicting views that you may have? Venki, why don't you? Because you've been working so much in the autonomous area.
All right. So, I mean, again, going back to Fan's point, right? Car companies, we have a product to sell, right? And if we have to depend on V2X or anything, it requires cooperation from government, and there's a lot of constraints. So, but good part about constraints, it also, progresses innovation. So that's where I guess more companies are, at least including ours and even Tesla, talking about same thing like what Dinesh said, right? End-to-end generative AI models, or not just generative AI models, just general learning models that can do autonomy, L4 or even L4, L5 autonomy kind of features, right? So that's where I think companies come from. I mean, it's not like we are against the V2X or anything. V2X being available, definitely, I think it can help. Kind of use cases that even Fan pointed out. If you're able to see beyond what the car can see, that's great. But you have a time constraint, and then all companies are already progressing towards L4 autonomy, and we are also already seeing kind of L4 autonomy being deployed. So, first when we say L4 autonomy, right, we should be careful. Let's start with the definition of L4 autonomy, right? L4 autonomy means that, you don't need any driver intervention within a certain ODD, right? And that has already been shown, right, in a certain ODD. Now, it all depends upon how big of a ODD that you have. So, even Cruise, Waymo, and even Shopping, you have probably heard of robo-taxis that are working decently well in their regions of interest and ODDs. And so it's been shown to work, and without the current V2X. But question is, as we move towards L5, is this sufficient to be able to expand to all coverages, anywhere, anytime kind of situation, right? That is yet to be seen. And I feel that that's still few years or probably even a decade away. So I think that would be my viewpoint in CV2X. And
very quickly, anybody would like to add? We need to leave a couple of minutes for the questions. Yeah, 1 minute left. Anybody would like to add anything? Okay, but
The role of connectivity is just super important. I don't see how you can trust a vehicle that can only see 3-5 meters.
All right. So I'll
Maybe
just...
one last thing. I think that when you really progression from L2, which is a many commercial deployment, or L4 and eventually L5, and more and the redundant and the sensor augmentation will be needed. So the connectivity and might gradually play bigger role. And when you saturate it to the last mile is always the most difficult mile.
Got it. And just very quickly, a trivia question. Since you guys are talking about Tesla, nothing to do with Tesla, but EV or ICE? I'll start with Siva. Okay. Just EV or ICE, just what would you prefer?
What would I prefer to drive?
Absolutely.
ICE.
All right, Nuria.
I think I like EVs.
All right, Fan.
I live in Ann Arbor. Ann Arbor is a green city, so my wife loves EV, but I'm still driving ICE.
definitely EV.
All right. The vote is on EV. All right. I'll open it up for questions if anybody would like to have any questions. Yeah.
Take the best human driver who doesn't really need connectivity. And I guess why does an L5 connectivity, if we assume a car drives by itself and no intervention, needs connectivity? Like, what's the driving conceptual understanding?
Has to do it better than the best human driver. That's the expectation. The idea is that with these systems, you are able to reduce
I'm saying the best human driver maybe had no accident the whole life. So there are many human drivers who had no accidents. So
the best human driver will never perform as well as a machine when the machine is really performing well, because it can be much faster, processing everything.
thank you.
I just had to add to that. the reason why you would have to be better than a best human driver is just the perception of the public, right? You can claim that, hey, my car drove like tens of millions of miles without any accident, and then there's one single accident that gets blown up in the press.
Totally
Then everybody starts losing, confidence. Right?
They
So
love to
that's-
talk about
they love to
such
talk about
accidents.
and then you have to shut down the program, right? So that's probably the main driving point from an industry perspective.
All right, I think we're over time, but thank you so much. Appreciate all the discussion with panelists.
Thank you.
Forward to the next session.